We are at part 5, find shortest distance from point A to plane GMB. And I make an observation that this plane GMB is the same plane we are talking about here. And how do I know for sure? BG is a vertical pillar, so B is vertically below G. If I have a vertical plane passing through GM, doesn't it include B? And therefore, plane passing through GMB must be the plane that we're talking about in part 4. Alright? Now I have a point here A with known coordinates. I know the coordinate to be 0, 8, 0. I want shortest distance. Now before I continue, some students will say, oh, Mr. Pang, I see that, there's a point vertically below M, which I know the coordinates, and then, I can connect it to A and it forms a 90 degree. Mr. Pang, anything with 90 degrees is shortest distance, right? Well, the answer is no. Let me illustrate. I have this plane, okay, and maybe this was M, this is the point here, and then vertically connected to some point A, and you see that this is 90 degrees. What if, because again this is a 3D picture, let me rotate to give you a different perspective. Same drawing. Okay. What if A is over here? And really what you're doing is this. Okay. Original point here is the original point here. Yes, it traveled down to another point and it goes up to A. And this is a 90 degree, but it's a 90 degree on a slanted plane. Is this shortest distance? No, no, no. Shortest distance has to be here, such that any which way you turn this plane, I don't care if you turn it up, down, left, right, you would always have absolute perpendicularness, so to speak. Okay. In this case that was present, there is a chance that it's not perpendicular all around. It's just perpendicular when you look at this, and when you turn it around, you realize, oh, it's only perpendicular on a certain way that you look at it. Yes, a 90 degree can exist, but it's not 90 degrees all around. Okay, so I hope that clarifies. You can't just take the nature in which it was formed and just say, oh, then that is the shortest distance. Not true. Okay, I can also take point A, bring it down here, and somehow assert that it's 90 degrees. Yes, it's 90 degrees. Yes, it is 90 degree. If you're looking at here. But if your eye were to be here looking from the other aspect, you will not see that it's 90 degree. All right. You want a shortest distance, it has to be 90 degrees no matter which way you look at it. No matter which way you look at it. So we can't use this special method. It is creative, but it does not hold. You have to revert back to your point plane method. I have a point here. How? Form your magic triangle. How are you going to form your magic triangle? Take another point here. Use the normal. You'll get this. Okay? This is the 90 degree. You use the two finger method. 90 degrees where you pinch your other finger. And you realize that this one is your cross. This one is your dot. Which one are we interested in? Shortest distance. This one, the dot. Okay, so that's our strategy. Let's implement it. Coordinates of A, 0, 8, 0. Equation of plane, it has been given to us. X plus 2y equals to 8. I want a point. I don't care which point. Just find any point. Okay. So point on the plane, this, which is what we want here. Okay. But any point, you just need to satisfy this plus this equals to 8. I always like to use 0. Let y be 0, then we just have x equals to it, right? If y equals to 0, there's no z here, then x must be 8. Correct? 8 plus 2 times 0 is indeed 8. So the point 8, 0, 0 must lie on this plane. I have artificially created one, but it's true. So this point here, okay, let me call it P3. Okay, so what do we see? I have my point, I have the other point. Oh, do I have the normal? I do not have a normal. Okay, so let me work with it. I do have the Cartesian equation over here. Cartesian to get me the normal. Can I do that? Yes. Go ahead and find any 3 points that lie on the plane. 3 points to get 2 direction vectors. 2 direction vectors to get me a normal. Okay, I have 1 point, so okay. Then I want another 2 points, right? Okay, let me call P4. Okay, now let me make x equals to 0. So y must be 4. What if x and y are both 0? Okay, never mind. Let me not go there. Let me just, well, let x or let y equals to 1. Okay. Y equals to 1, x 8 minus 2 equals 6. So I see that another point again is 6, 1, 0. 3 points, find 2 direction vectors. That's 8. This is a direction vector. I'll go and simplify that. This is a 0. Let me do P5, P4. Just one thing to note, I always want to make sure that the endpoints are the same, because I want to have this thing going on. Okay, I want them to be converging. Then when I cross, I know that it's a line that passes through them. So it's OP4 minus OP5. Again, I can simplify, and oh dear, I think I'm gonna see something. Why are they parallel? Why are they parallel? So I've just chosen an extension point. Okay, I guess. Let me choose another point then. Okay, y equals 2. No, let me see. We see that z can be anything. Okay, when let me say it this way, when y is 1, x is 6, z can be anything. I see, I have understood. Okay, observe that all these points are all on z equals to 0, which means that if I were to draw my plane, right, isn't this the y-axis? If z equals to 0, this is the z, right? If z equals to 0 here, that means all these points that I'm choosing, P3, P4, P5, is somewhere here. then they are collinear. Collinear means parallel, as seen in here. So I do not want to do that. Since the plane is vertical, for any point I can just vertically shift up and shift the z coordinate up, correct? So let me just do that. How do I do it? I don't even need this point anymore. I don't need this. I don't need this. Let me just take some point like this and shift it up by 1. What I'm doing is something like this. Something like this. Okay? Vertical. Alright, with that, what would change? My P5, P4, this one over here. What would change is this. No, no, no. Yes, 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 correct. Okay, I can, it's a bit mischievous, but let's pull out -1 so that I work with 0, 0, 1. I prefer that. Just preference. Okay, very nice. I have 2 direction vectors. They are non-parallel now. I'm going to find the normal. Cover top, prepare negative, cover middle, negative 2, cover bottom, 0. So normal is 1, 2, 0. All right, let's check out my plan here. So now the normal I have. So the 2 points and the normal I have, magic triangle can now be formed. 8, 0, 0. This is A. Normal equals to 1, 2, 0. And we wish to find shortest distance. Check it out again. Put your 2 fingers, pinch the finger with the 90 degrees. You see that the shortest distance is the dot version. All right. Shortest distance equals to, what are 2 vectors that I have? P3A dot hat. All right. So I'll carry on for the sake of this one. I'll carry on and solve it. OMA minus OP3 dot unit vector of n. Okay, this one over here, this is just a number. I can just bring it out outside the whole modulus. Rationalize denominator. So this is the exact answer. Let me just compute to see what we have. I777 3.58 units GSF. Okay, and there we have the answer for part 5, shortest distance. Answer as such. Okay, so the entire question is from ACJC 208. Entire question, we took quite a bit of journeying. Okay, it very nicely tested most of the topics in vectors you ought to know. Heavily tested the visualization question. As we expect from an applications question, visualization. And it's a lot of there's a point plane, there was line plane, Okay, all those. Very nice testing. The interesting concept that we have to figure out here was the verticalness. This thing, vertical. All right, we had to conclude certain characteristics and form this understanding, right? The xy being the same, and also that GBM is the plane of a vertical plane solely passing through GM. Okay, this link that we have to form, otherwise we would have been unable to solve this question. Okay, please rewatch this as many times as you want if you have any confusion. All right, I wish you all the best.